Hey y'all. Today I'll be reviewing a simple tech stack with the goal of highlighting some local Kubernetes development. We'll be creating a monorepo using TurboRepo for a Node.js based project. It will have a Next.js application in it that will have a simple component and some API endpoints. We'll be spinning up a Postgres database. We'll be using RabbitMQ for a queue, and we'll be scaling a worker node using event-based auto scaling provided by the Keta project. I wanted to do this because I think it's very important to understand that Kubernetes is not as hard as people think. It's crucial to understand that it can be ran anywhere. That means your home lab, an on-premise data center, or a cloud provider, or any hosting provider where you can spin up servers and just set up Kubernetes yourself. Unlike a lot of cloud providers that have serverless architecture where you can spin up lambdas or whatever. Uh, those are associated with a kind of a dynamics flexed cost based on usage. A Kubernetes cluster could be set up that way, but in general, you can just spin up a high availability node for 100, 200 bucks, and that's a fixed cost. And you don't have to worry about things like a spike in traffic or a malicious actor DDoSing you that would potentially push the costs up and skyrocket them for us what you would normally have with a serverless hosted provider. The other value of this is that not all cloud services have local emulators. There are projects, for example, that provide that for AWS, but for the most part, most of the services require developing on the cloud. Uh, there are some ways around that, but for the most part, you're using cloud services to develop, which could also cost money. And that's okay if you're working on a commercial product and your business is all right with eating those costs. But I've talked to a lot of people that have started using the clouds, Azure, AWS, Google, and in a traditional corporate environment where they're used to spinning up full servers. And I've heard some horror stories of costs going into the hundreds of thousands, if not millions of dollars a month because the developers just didn't have the right training and aren't familiar with event-driven architecture in a way that works for cloud-native designs. Um, generally you want to spin things down and spin things up as needed. And when you're running virtual servers and whatever concurrently with everything else that an application may need in a traditional monolithic app that runs on servers, um, it's going to cost a lot. So we don't want to do that. So Kubernetes can help with that because it forces people to sort of build containers and work through that process of understanding how cloud architecture should be done or can be done. And then I really believe that Kubernetes is the future for a lot of medium to large complex applications. It's Kubernetes itself is maybe just a scheduler for managing containers, but uh, the real magic is kind of going over to the organization that incubated Kubernetes, the Cloud Native Computing Foundation, and seeing everything else they have on their landscapes page. If you go through and look at all those different projects, you'll see that they're essentially giving you a lot of the crucial services offered by a cloud provider, but they're open source and a lot of them are geared to run on Kubernetes or some sort of containerized platform, which allows you to have your own cloud, if you will, and just rely on the compute and storage and IO and all that kind of stuff that cloud providers have. Without being locked into those really heavy variable costs that could be associated with poor architecture, or just heavy usage. So that's why I'm making this video. I've been sort of diving into all of the CN, CF incubated projects and learning about them. So this is kind of a kickoff to that, and I'll be continuing to do this as I learn more of those incubated projects and see how they can fit into different types of tech stacks. So I hope you all enjoy this, and this is gonna kick off this video. All right, so the first thing we need to do is get our Kubernetes local node set up. I've used Docker Desktop, I've used Rancher Desktop, Podman, all the different flavors of just, getting things running. And then also all the different ways of running a Kubernetes cluster with Kind or Minikube or whatever. Um, I've had a lot of issues with Docker Desktop over the past few months, stability issues, user GitHub issues, there's a lot. specifically for M1 Max and Macs in general. I find that Rancher Desktop just works. It spins up a K3s node, which is simple. It doesn't have all the bells and whistles that Docker Desktop has, but it works. So I've been tending to stick with that lately. It has containerd out of the box. It's not a beta feature, so yeah, that's just where I'm at right now. Maybe Docker will get better in the future, but uh, Rancher Desktop feels more pure to me as far as being close to a true Kubernetes cluster. If you have any issues, you can go into this troubleshooting tab and kind of reset stuff. Sometimes you have to. It's a thing. And then I also remove collection of statistics here for setup. I have 64 gigabytes of RAM on this box, so I'm going to set it to 32, give it 6 or 7 CPUs. It's probably not necessary for what I'm doing, and I will set resource limits on all the deployment configurations for the containers, so it's more of a, I can do it, so I'll give it the resources. So this is going to spin down and then spin back up again with all the configuration changes that we've made. And then I'm going to do a quick demo here of the Rancher desktop dashboard, which is similar to Lens or the Docker web management application that they give you. Basically, this is going to spin up a GUI where you can review your node, resources being used, payloads, secrets, whatever. I find it useful to have something like this available just to quickly go through and review things. You can do all the same stuff in the CLI. It's whatever you like. I like to have this open and kind of check it out as I'm developing to kind of keep an eye on things without having to issue commands constantly. So yeah, this is pretty much it. All right, so now we're going to check out setting up our monorepo. I've been using Turbo Repo pretty frequently lately. It's made by Versal, the same people who make Next.js, and recently announced Turbo Build. We're just going to use them to kind of facilitate the monorepo design pattern and use all the tooling that they have. You can check out all their features later if you're interested on their website, but for now we're going to go to their GitHub. Inside their GitHub, they have a examples directory that has a bunch of examples for a variety of different use cases. We're going to pull in the one for Docker first, and then eventually use the one for Prisma. But the Docker one will get us going, and then we can change it up once we need to pull out anything from the Prisma example. We're just going to go in here. We're going to use npx to pull down that particular example and create it into a project. We're going to call it local Kubernetes development. Once we have that, we're going to do a yarn install on it and then do an initial git commit so that we can have our source being tracked as we go through this process. I eventually am going to publish this project on GitHub, and it'll be available for everyone to check out and use as needed. So for our initial project setup, we're just going to go in here and just kind of clean up some stuff. So I'm going to use VS Code. I'm trying to do everything in this open source as possible. I use other IDs, but VS Code works perfectly fine for what we're doing here. Yeah, so we don't need any of this TSX file. We're just going to kind of navigate through this. We don't need the API. We're not going to use that. We're just going to use Next.js. Next.js's built-in API. And then let's see what else we can clean up in here. Yeah, we're not going to use this UI directory. This is kind of just an example of how to use Turbo Repo in order to like pull in components into your Next.js package. So we're not going to use that, but we will add some other stuff here in a minute. Cool. So here's just the Turbo JSON configuration. We'll be adding more to that later, but for now, that's pretty much standard thing. If you want to learn more about Turbo Repo itself, I would just go read their docs. They're very good. All right, so we're just gonna just delete everything in here because we don't really need it. We're just gonna put in a more simple example that just renders a component here. Next, we're just gonna build Turbo Repo to see how it works without doing anything special. Yeah, it'll take a second. And then after this finishes, we're just gonna run it in dev mode. All right, looks like it's up and running. Let's test it out real quick. Cool. Hello world. We'll modify it just to show that the hot reloading works in the developer example. Cool. It's working. Let's modify it one more time so we can get into just basic state. All right, cool. Next, we're just going to check out the Docker file. We don't really need the Docker Compose. We're going to get rid of that right now. We're going to add everything else in using Kubernetes later. There's a logger in here. So we're gonna add a better logger, not just console log. We're gonna throw Winston in. Winston's a pretty standard logging package for Node.js. Maybe one of the more popular ones. I don't know. I've used it in a lot of commercial projects. So we're gonna go in here and kind of show you how to do that in Turbo repo. Basically, under the packages directory, there's a logger directory. We're gonna go in here. We're gonna just add in the Winston dependency. So it's not in there yet, since this project wasn't really using anything, this package for Turbo Repo. So we're going to add in Winston, and then we're also going to add in the type for it. Otherwise, it's not going to be happy. All right. Cool. We're just going to install those packages now. So now we're going to update this. I'm going to have some snippets that I'm going to copy and paste throughout this to kind of speed things up. This is a pretty standard snippet that you can just grab off their web page. There's nothing special. It's probably in the GitHub repository on the README. But this is a very basic Winston configuration. All right, so what we're going to do now is we're going to create an API. Next.js makes it pretty easy. They have a convention of just creating an API directory under the pages directory, and it'll just follow the routes based on your naming conventions. I'm just copying and pasting some boilerplate code in here so that we can have a get endpoint that just returns a ping pong response in JSON. Eventually, we're going to do more with this, but right now we're just going to hook up our logger to kind of see how that would work. So we're going to import our logger above just based on adding it to our package JSON here. So now we're importing our logger. Once we get this in, we're going to update some of the code below here where it has the console log and just put in the logger because you don't really ever want to be using console log anywhere or console error. So previously, we were kind of casting the error to get the message out with the TypeScript type down below. We're going to use that in our logger now because we actually want to see the exception in our logs, and then we'll update the message below to have a generic error. So it looks like there's a problem in here. I'm not sure why yet, but we'll update the other. We'll update the generic message for now and kind of see what it tells us is an error here, because it'll tell us pretty quickly. So try to build it. Oh, I see. We have some tests that are failing because the tests were looking at just a log output that was from our previous code. So we just gotta get rid of that. So just make sure that's it. Okay. Yeah, that's pretty much what it looks like it is, I think. So we just delete the test directory, it'll be fine. Usually you want to have tests. I mean, I put tests in pretty much everything that we do commercially, but right now we don't really care because this demo, it's irrelevant. You can learn how to write tests on your own. All right, so we're just gonna hit up this API endpoint and make sure it works. Cool, the responses come back, so we're good to go here. there's anything special about this other than a place that we can pick up later once we get our database added to the project. We'll throw in another logger info here. It might be useful later on. I tend to log a lot in all my applications. A lot of them are event-driven architecture, so you want to be able to get as many logs in there as possible, just kind of know what's going on because they're so distributed. Uh, but I tend to do it in all projects now just because of some previous experiences with tracing down stuff. So now we're going to look at Tilt. There's a ton of projects out there that do what Tilt does, but Tilt is essentially one of the many developer-centric tools that you can use to do Kubernetes locally. It allows you to run Kubernetes clusters locally and auto deploy to them. Has a bunch of nifty plugins that you can do. Docker recently acquired or hired everyone from the Tilt project, so I guess they're supporting them now. So that's why I'm picking this because it's going to get popular. Pretty much all that requires is a tilt file, and that you grab these two dependencies over here. My context is already set properly, so I'm not going to do that. And I've already installed tilt, so I'm not going to do that there. I'm just going to put in a simple little print so you can kind of see what that looks like when we spin tilt up. Tilt comes with its own little website interface, which is super handy for looking at logs and just managing your containers and seeing what's going on. You'll see here that it's loaded, but there's no resources found. So we're going to start adding in resources to it and kind of get things going. The first one we're going to do is do a nerd control build, or it's very similar to Docker build. Nerd control is kind of like one-to-one command-wise for the most part. So we're going to build a web app image with our Docker file that we have already had that came with the project, and set the context to the root of the project because it needs everything in the root of the project because it's using the monorepo to make it work. Once our images is built, Tilt requires adding a Kubernetes resource. So we give it a name. You can do port forwarding here to make it easy so you don't have to do that manually. You can have dependencies, but we don't have any yet. And labels kind of dumps it into a folder under the resources on the right-hand side, which you'll see once this renders. So the next thing we're going to do is I like to create a Kubernetes folder in the project and put all my Kubernetes configurations there. That just keeps it organized. I tried putting it in the project directories themselves for app or whatever you do, but I prefer this. I mean, you can do whatever you want. I don't know if there's really a convention. So we're going to create our web app Kubernetes configuration here so that we can point to it. So Tilt requires all these things. So here's just a basic deployment configuration with web app for pretty much all the naming conventions, and then it uses a web app image, which we named earlier. I put some resource limitations on it just to keep it from taking over too much stuff, too many resources in the Kubernetes cluster. And now we're going to define our Kubernetes configuration for that web app here. So you just do a Kubernetes YAML, point to it, boom, says successfully loaded. You'll notice that it's there, and now the image is going to build. You can override these things, but it wasn't building before because there was no definition for it. So this is the basic configuration for the Docker file that came with the project. So you can check that out. We're going to change that later because it doesn't work for what we need to do because I have an M1 Mac that we're using right now. But we can dive into that a little bit later, but not that important for the demo. So this is just kind of the vanilla version that you had seen before, and kind of saw that all worked. But so now we're going to add the database just to kind of progress here a little bit. There's a bunch of projects that do database operators for Kubernetes. There's kubedb, there's kubegress. kubed is pretty cool, but it's a lot more complicated than we need. Kubegress is a very simple project, and we'll be using that instead. It just uses the base Postgres images, so I don't have to worry about building issues with custom images because of the M1. So we're just going to grab that operator and just sort of paste it in here, and it's going to apply directly to our cluster. And once that operator's in there, now we can create Kubernetes deployments using that custom operator. So we're going to do that now. We're going to create a directory called database, and in that directory, we're going to add a file here for the deployment. It's a pretty straightforward configuration. You can do a lot of different configurations with this if you go into their documentation, but for the most part, we're just going to kind of put in some very basic stuff in here. So I did put in a config map just to kind of show you this is how you can override some settings. We're going to delete it because we don't really need it, but I had used it for a more production project that I needed to tweak some settings. But for us, we can just use the very basic configuration that it starts off with. In here, here's just the Kubres kind type for what we're doing. The deployment, we have some environment variables set, and we have some resources set to keep it all constrained. It's all very basic. In a minute, you'll see this .env key secret key being defined. It's not in there yet, but we're going to do that next. I like to have a .env file that can be used by customize to then just deploy in, you'll see here, any of the secrets that we want. So it's like similar to like a local environment variable setup, but for this, it's just going to be for Kubernetes itself. So again, I mentioned customize, just so for those of you who aren't familiar with it, it's just kind of a built-in way of adding more configuration management to your Kubernetes project. We're using it here just to pull in that .env file because it has a nice parser for that, and it works pretty well. This is how we're going to set the baseline Postgres passwords, and they'll be defined here using that. These are the overrides that the Kubres allows you to do for doing that. I'm going to kind of shrink down the resource requirements here because we don't need anything special for this project, and I am running on my Mac. It doesn't have as much power as some of my other boxes that have a lot more memory and multiple CPUs. So we'll just kind of shrink that down a little bit. Yeah, we don't need as much database size either. Yeah. So once we do this, we'll kind of fire this all up. So we'll save that. All right. Now we're going to add all these resources to our tilt file, and we'll see it all kind of like come together here, just so we have an active database. All right, so there's our .env file. You can kind of define resources specifically in tilt, just because uh, if you don't define it as a K8 resource and give it the objects path, it will not know what it is, and it'll put it under kind of like a unknown container. We want to kind of get everything labeled here, so we've done that. We've used their custom function here to kind of parse out those secrets, and then you can just dump those right into a K8 City YAML once it parses it. Again, Tilt has a bunch of like custom helper functions that you can go through their API and figure out what you need. It does it for everything. You can even throw like a Docker Compose file in here. So super handy, super easy too. Their docs are great. So now we've got that set up, and we've seen that our secrets have been deployed. We're going to pull up the dashboard here in Rancher and just kind of look and see, okay, there are our secrets. So we're good to go there. Our database secrets are in there. And now we can start defining our database itself now that the secrets are defined. Yeah. So same thing, define the resources. You'll see the objects path there. So it is defined so that we can target, and we're putting it under an infra directory. It is saying that it doesn't know what those things are yet, so we're gonna figure out what the problem is with that. Oh, yeah, the deployment file wasn't in there. Okay, so now our deployments are defined, our database is going, and the database, now that the deployment is defined, and the configuration is defined for the deployment, it's going to start pumping it out. So it's going to pull down the image, it'll build it, push it. So now we have our web app, our database, some secrets, and I'm going to speed this up a little bit so that we can kind of crush through it, not waste time. All right, our database system is up and ready to accept connections. So we're good here to go on to our next step for what we're doing. One last thing, I just want to kind of just show the database in here. You can see there's our web app. And then if you go to stateful sets, you'll see the database, and it's being deployed. It's handy to kind of go into the dashboard and kind of visualize it. You can run the commands too using queue control and node control, but it's not, I like pulling up the dashboard. It's a little bit easier to visualize at a quick glance. Yeah. So let's see. So now we're going to want to go into the examples that TurboRepo has for Prisma. It's a little bit different. So we're going to just go take a peek at their example repository in here and just sort of show you this is what it looks like. This is sort of the configuration that you need to put in for Prisma. I have some stuff already prepared that I'm just going to kind of like dump into here just so we have it. The major difference is that there is no TS config that they are specifying here for node 16 in the Docker example, but they do have it in the Prisma example. So I'm just going to copy and paste that in a second. I'm going to update the seed TS too, so that we can get just some unique data in there other than their baseline example. Let's see here. So that's done. We'll continue on. And this is all the stuff that's generic from their example. Nothing's been modified. So you will notice that the TS config here though is using node 16. We're just going to pull that over from another project. I'm just making sure there's nothing else in here that we need to verify, that we need to move in. Yeah, see, it doesn't exist, so I'm just gonna grab it and copy and paste it in here. Yep, there it is. Cool. So now we're good to go there. Next thing we're going to do is we're going to import the database dependency here, as you do in TurboRepo. So now the web app's updating. It's going to take a second here to do that. All right, we'll see from this here is what I was talking about earlier. I do have binary target set to native, and this should work. But if you go on the Prisma GitHub repository under issues, you'll find quite a few fun ones with the Apple Silicon ARM processor. Stuff just isn't working as expected. So we're going to get this all imported here, the database imported into Prisma. I'm going to update the example to use Prisma. So we're just going to pull our user object back from the schema. This is just the default schema they have, which is just has just like a user in it. So now we're going to dive into some of that ARM fun that I was talking about. So basically the issue is that if you're using an M1 and you're trying to build on Docker, Prisma gets kind of wonked out when it tries to build the binary image that you're looking for your platform. There's a few ways to fix this. I just opted for one of the easier fixes, which is not using the example for the Docker file they give you in the examples under TurboRepo. It is a nicer Docker file. It has layers to it. It's way more efficient, but this is the Docker file that I came up with. It's one layer as far as like not sharing different stages, and it just kind of works. It doesn't use the Alpine base image. It uses the LTS Bullseye base image, which is one of the ways that you resolve this issue, is making sure that it has all those dependencies in place. So now that we put that all in place, it is rebuilding again, and we're not going to have the issue with Prisma not being able to figure out what binary to use. Next, we got to configure the environment variables for the web app. Now that we have the database, it just needs a database URL. So in order to do that, we're going to drop in some values from our previously used .env that we used previously, and build a connection string out, and now it has access to that database. It's going to rebuild again before I can do the hot reloading. It is saying something blew up, so let's go check out the logs again. Okay, the app doesn't exist, so we need to migrate the database and actually create it with Prisma. Let's install the dependencies first, and then now we're going to run Prisma migrate dev. It's going to lay down the schema. We need a local environment variable file as well. So you make sure you just don't check this in, but this would go into the root directory of your project. So I'm going to add that in real quick here. Okay, there it is. The connection string we want's all in place. And then we're going to make sure we just, all the other ones are kind of done in, but let's just do a .env to remove that as well there. We're never going to use that in production. We're going to inject the environment variables in. All right, now that it's in place, we're going to run that command again. It's going to lay down the database schema for the current version. We're just going to call the initial migration init. Once that's done, we shouldn't get any errors here. Yep, there's no users in there, so now we need to seed it with that seed file we updated earlier. So we're going to need to do some stuff first. We're going to go look at the npm command that is in the package for the database, because we're going to need to add that to our turbo configuration here. And once it's in our turbo configuration here, we can just run it by doing a yarn run turbo, and then whatever your npm command is, it just kind of links together, which is nice. Okay, awesome. That's going to be in there now. So when we go to refresh, there should be a user in there, and there is. So we're good to go there. Great. So this is going to finish building here, and then we'll have the hot reloading again once it does whatever it needs to do for its main dependencies. Yeah. All right. Well, I keep saying hot reloading, but now we're going to actually add it in, so we don't have to wait for it to build every single time. The first thing we're going to do is we're going to add in some ignores. So what this does is if anything changes in these directories, NER control or tilt's not going to run the command to rebuild stuff. So we're just going to ignore anything that's in the Kubernetes configurations files because it shouldn't matter, particularly right now anyways, but it will eventually matter. So we're going to throw in, you can look at all this, it's all available in the tilt documentation, but basically we're going to use the built-in command that TurboReveal gives us and filter out only for the web project. And it's going to sync everything from the root directory to the app directory and the Docker container. So once this finishes doing its initial build, it's going to rely on the functionality that Tilt has built in to just sync the file system directly, so we don't have to worry about rebuilding every single time. So we're going to get instantaneous hot reloads. So we can just kind of example this here. Cool. All right. You'll see that if we go over to this, so we change this here. Okay, we're going to save it, and you'll notice that it uploads here. Oops. It appeared here pretty quickly. Oh, maybe not. Oh, okay, it just had to get resynced again. So let's just refresh it. Now it looks like we're having some sort of like port forwarding timeout issue. It's probably just resyncing now that we're changing from to hot reloading. So let's just give it one more second here to refresh. Yeah, there we go. Okay, cool. Now it should all be synced up and ready to go for quick hot reloading. Some of this stuff's kind of wonky sometimes. So you have to just kind of pay attention to it, but you'll see here that it's instantaneously reloading when we change things without having to rebuild the image every single time, which is super nice when you're trying to get stuff done and you're used to like local development. Sometimes it takes a little bit of time to kind of tweak the settings to figure out what you need to hot reload, but this is an easy example to kind of show you that it is possible. So now we're going to go through and just kind of update the README, to put down what we have and what we're building, just so we have a point of reference. I'm going to publish this project on GitHub publicly at some point. Maybe not before I release the video, but in the coming days after. So we're just going to kind of define our objectives here. This is a really basic project that we're just trying to kind of do a proof of concept how to develop locally for Kubernetes. So we're just going to highlight that here. There's tons of topics here. If you have questions, I can add more in-depth videos for specific topics. But for this individual thing, it's just gonna, as it says, create a simple project that highlights a basic development environment with Kubernetes. And that's pretty much it. Let's list some of the things that we're adding to this project, just so we have a reference and that people know when they look at the project if they want to know. We're gonna add a web application. Let's rewrite this a little bit. We're gonna add a database. We're gonna add a web application. Okay. We're gonna add a queue in here in a little bit to kind of demonstrate how that works, so we can demonstrate auto scaling. Yeah, we're gonna do event-based auto scaling using Keta soon. That'll be part of this demonstration. I guess, yeah, it's an API as well. Yeah. All right. And yeah, I guess we're demonstrating that it's a monorepo as well. That's important to mention. All right. Yeah, and I'm kind of just like a disclaimer statement. I mean, this is a proof of concept that I put together in a quick afternoon, mostly without any edits and research. So, yeah, and got to put the disclaimer since people don't do anything crazy like push this out for something important. Yeah, this is not a set of best practices for Kubernetes development or deployment. It's just an example of how you can do it very quickly. It's not a set of best practices for event-driven architecture. Definitely not. There's a lot more that goes into it than just this. This will get you started. And then definitely not high-quality code or testing. This is pieced together with just off the top of my head examples. And we'll probably could go into more detail with some stuff later, but learn those things from smarter people. And then as far as the tech stack goes, we're going to use TypeScript in here. As you can see, I don't really write much JavaScript anymore. I don't advise anyone else to. Rancher Desktop, you could use Docker Desktop. It doesn't really matter, but we're using Rancher Desktop here. Next.js, easy API, with rendering, great way to start off your React projects. Prisma for our ORM. Super easy RM. Tilt to kind of facilitate this Kubernetes-based development. There are other projects. We can hop into those later, maybe. And then Turbo Repo for the monorepo. We're using Kubegress for our database operator for Postgres. And we're going to be using RabbitMQ for our queue. It works well with Keta. It's super easy to get going on that. And they have like an official operator that VMware created, I guess, and maintains. And then Keta for our auto scaling, which is a great open source project for scaling on a bunch of stuff, not just queues. You can scale on databases or CPUs, and it makes it really easy to just lock your application into some event-driven architecture that you might not have been able to do before, right? Just lock it in. Yeah, and I guess I'm going to put some configuration stuff down here. I'll probably add more as we go, but basically we need to make sure that we at least note the operators that we're adding to this, because they are doing all the heavy lifting. I'm just kind of creating simple deployment files, and those are the things that are really powering this project. So that's the Postgres one. I'll add the Rabbit one and the Keta one soon here once we get it going. But this will get us a nice little baseline README, and it'll definitely be more robust when I publish this project. For now, it's just gonna kind of keep us on track of where we're at and where we're going. All right, so let's add that queue. So RabbitMQ is a very popular event-based queuing service. It does a lot of stuff. It's not the best for everything, but it definitely works well for some things. With anything, just do your research. This is more of just an example of something you can do fairly easily. Here's their Kubernetes example, and here's how you can just get it in your cluster. So you just copy this configuration to deploy the operator. Once it's in there, we're going to create another directory here called queue. That queue directory is going to have another deployment configuration in it, and it's Very simple. All right. So we're defining the resource here. We're going to open supports up, uh, call it queue, drop it in the the infra directory over there next to the database using that label. All right, and now we're going to just get our queue going by just pointing it to that configuration file. We'll see here that it's going, it's pending, and this cool thing about Tilt is it kind of keeps track of all this stuff, so you don't have to. Uh, let's see, what's the issue? Let's look at the deployment here. I must have had some not saved it or something like that. Or, anyway, it's working now. All right, everything's up and running now. It looks like. So now we're gonna hop into something a little bit different. Now that we have our queue running, we're gonna add our worker. It's just gonna be a simple Node.js process that runs. We're gonna create a worker directory. I'm gonna copy and paste some stuff in here. You can pretty much ignore a lot of this. It's just a basic project with some ability to do some uptime. The Docker file is identical. The only difference is that we're calling it a worker in here for some of the directory paths. So it's nothing really special going on. In here, we're going to create a source directory. In that source directory, we're going to create an index TypeScript file. We're going to import the RabbitMQ library, the most popular one, and our logger. And then we're going to create a self-executing anonymous function to just run when this process starts, when this is executed, when this file is executed. Yeah. And then in here, we're going to start piecing together some stuff. So first thing we're going to do is just do a yarn install so that we get all of our libraries and everything in there, and we don't get any weird squiggly lines. Nobody likes those. We're going to add an ignore for our web app image for the workers because we don't want that triggering every time we change the worker file. In here, we're going to add in some environment variables that we're going to grab right off the bat, so the QRL and the worker name. And if the QRL doesn't exist, we're just going to kick it back and throw an exception because we, just can't run without that. We're going to create our connection down below. Let me just write the comments in here for this first, actually. Okay, yeah. And then we're going to create our connection to our RabbitMQ instance and then create a channel on that connection. All the queues work over channels when you're sending and receiving, so it is required. Now we're going to add a little logger statement down there that says we're attempting to initiate a worker. So now this is saving. We're going to go and we're just going to take a quick peek at this library so it exists. There's a lot of documentation. They have examples too, but for what we're doing, they're pretty basic example. We're going to hop on the dashboard real quick and we're going to pull that up so that we can see that the queue is in there, just to kind of show what that looks like as we start deploying these custom operator deployments. And we're going to see that the secrets are actually stored in this auto-generated for us in this queue default values. And RabbitMQ comes with a nice interface out of the box, web interface. So we're just going to grab these values and log in and sort of just see that there are no queues in the queue currently running. So now to make this work and scale horizontally pretty nicely and not having to create multiple images for all workers, I like to just create a switch statement that uses an environment variable that can be passed in during the deployment that specifically defines the worker by name. So we can just create multiple deployment files, change the environment variables out to be our different workers, and then it'll know what queue to access based on the potentially the queue name or the worker name or however you want to design your switch statement. It's an easy way to kind of keep the overhead down for being able to horizontally scale containers, which we'll do later. We also have to add some of these things into our turbo file for environment variables. Just if we were to run it locally without all of this magic, we want it to be able to work as expected. So we just kind of keep adding in things to the turbo file as needed. So here's our first case statement for a worker ping worker that we're going to be creating. In there, this is where we will essentially use that queue channel to do things. So first we'll just throw some logging in there saying we're starting the worker for this particular worker name. The queue channel, we basically have to do an assert queue on it, and this will either create the channel or make sure that the channel you connect to has these configurations. I believe but it is required there to just kind of make it work if there isn't a queue established already, and then we'll break. But the next thing we need to do is we need to write the function that's going to actually run this queue. Right, so it's the function that's actually the worker that's going to connect to the queue. So we're going to create an async function that has a channel passed into it, which we're creating above. We're going to just put a try catch in here. Eventually put a finally so that we can send the acknowledgement back with the message that comes from the queue. We have to import the channel from that library so it knows what it is. We define our types here in TypeScript. And now we're going to set a channel consume, and we're going to put in our worker name here, our queue name that the worker is going to be consuming messages from. And we're going to wrap that in an async function. And then inside there, we're going to put our try catch. Inside the try, we're going to check to make sure that there is a message and it's not equal to null. So just a quick check there. If there is a message, we're going to parse the data, getting the message content and turning it to a string. Once we have our data available to us, we're going to assign it to an additional variable, to ping variable, and then we're going to log that. Because we don't really want to do anything with it. This is an example, but you could do something like process it, pass it to another queue, store it in the database. I mean, that's going to be up to you based on whatever you're building. But here we're just going to show that it came through. And then we're going to write a function that just takes that ping data object and processes it just so we can show how that what that may look like if you're trying to deconstruct or restructure all your project to have its isolated purposes for your functions. So generally you'd have something consuming, a function consuming the messages, and another function processing them to keep them clean and testable. So in this one, we're just going to do another logger. So when we look at the example later, we're just going to see a couple of logger infos, dumping two different types of messages, essentially establishing that this does work. And we're just going to output the value of ping, which is super exciting. And then you don't have to do this, I believe, in Rabbit, but for us, just so that we, do a little bit more, we're going to, in the finally statement of the try catch, no matter what happens, we're going to acknowledge that the message came through and that we at least sent it for processing. We don't guarantee that it's been processed here. We could, but and then we're going to log any errors that come out with our logger. All right, cool. So now that we have our worker set up, we're going to need to add it to our tilt file so that the image gets built and it gets deployed and it shows up here. So we're going to do another nerd control build here for that Docker file. Again, we're going to have one Docker file for all of our workers as long as they have the same dependencies, and be able to deploy them horizontally with different worker names based on an environment variable. This one's going to be worker ping. We're going to add some ignores in here as well, because again, we don't want to rebuild this if something in the web application changes. We only want to rebuild it if something relevant changes here. So those two are good ignores for now. Keep things simple. We're going to want to define our Kubernetes resource here for the worker. We're going to give it a name of worker ping. Just verifying that that's the name of the worker that we put in here, hard-coded. Probably should have found enum for that somewhere, but for now, just roll with it. This is a very rough proof of concept example. And then we're going to put this label under the workers category so that all of our workers, if we had more, would fall under that to make it easy to kind of see them within the Tilt project configuration. So now we're going to create our Kubernetes resource file for this worker, the worker deployment. All right, now I'm just going to speed this up real quick just so we can fill this out. It's nothing special. It's just another Kubernetes deployment file. We're going to move in environment variables for both our database and our queue in there, and then we'll have those available to the container when it's running. All right, we're just going to copy and paste this and add one in for that deployment configuration that we just created for the worker. And then there's also troubleshooting that may come along with this when things break. So it looks like the issue here is that there is like some formatting with our tilt file, or maybe not the tilt file, maybe with the deployment YAML. An easy way to solve this is just install the Kubernetes extension or whatever ID you're using. VS Code has one, so it makes it really easy. Once you install that, you're going to have syntax highlighting in all of your Kubernetes configurations. And we're going to see right here that basically it's a formatting issue. So we're just going to fix that real quick. And then everything's good now, and it's going to start building that worker. Sped that up a little bit too. Once the worker's done, we're going to add a ping endpoint so that we can add stuff to that queue for the worker to process. This is going to be fairly straightforward, but what we're going to see here is that the queue has started running, but nothing is happening yet. There's nothing in that queue. So we're going to create another endpoint here. It's going to be called, I don't know, we can call it ping, ping endpoint. So we're going to just copy and paste our previous example in here, and we're going to clean it up a little bit. So we don't need the database in this example. What we need is we need a connection to our queue. We're going to import that from our AMQ plib library, or the library I showed you before. And we're just going to gut out all this database specific stuff that we don't need here. We're just going to return back a 200. I don't care about a response here. And then we're going to throw in all the stuff that we previously put into our worker for the worker ping queue to connect. But this will be specifically for our API endpoint. And they're going to be fairly similar. It's just this one's going to send a message versus receive a message. So we're going to get our queue URL in. That's going to be passed in as an environment variable. It doesn't exist. It's going to blow up, and we want to throw an exception here so that we can figure out why. Once we have that, we're going to create our connection using the QR URL that we have imported in for our environment variables that we had set previously in our deployment configuration. Or we may still have to do this for the web app, but for now, we're just going to put this in here. We'll figure that out in a minute. We're going to open a channel to the queue. And then once we have a queue channel available, we're going to be able to assert there is a queue. And then if there isn't, we'll create it. Just basically just as a way of creating the queue and making sure that it's what we want. You can put in a lot more configuration options, or just give it a name. So it's just basically saying, does this queue exist? No? Okay, create it. And now we're just going to send something to this queue. So we're defining it again as a worker ping. Probably should be an environment variable. We're going to create a buffer using a JSON string of just a ping. We're going to throw a little message in there. Hey there, little wave, kind of deal. And we're going to send that to our queue. A lot of the examples do a set timeout. So we're just going to do like a quick 500 millisecond wait here. I don't know if it's really needed. I haven't really used RabbitMQ that much in this context, so I did miss some messages by not doing this. So this is just what they have in their examples. So I just did it, and it seems to be pretty foolproof at this point. Yeah, so we're gonna need to add in our queue library here into our packages, just so that the web app has access to the types and the queue library, so it can pull in and messages from the queue and send messages to the queue. Mostly send, probably. Unlikely that it would pull. And then we're going to make sure that all those environment variables are set so that it can access the queue based on the configuration. And you'll see a lot of this is shared. Eventually, you could use customize to kind of inject this in everywhere. But for now, we'll just keep it copy and paste. So we're going to go to that endpoint, and we're going to see if it adds messages to the queue. It should. So we're just going to hit enter here. Oh, we got an issue. It's probably because it hasn't finished building yet with those new environment variables, or maybe the library. So let's let it finish building here. Once it opens up again, or shows that its connections are open again to this new container, we will go back. Okay, cool. No errors, no errors. Now let's go to the web interface. Oh, yep, there's 2 queue messages, so we're good to go there. All right. There's a lot more in there now. So now our worker is not processing messages. Let's see why. It looks like I never call the worker ping function in that switch statement. So let's add it. This is going to take a second to build since we don't have hot reloading, but that's okay. Well, it also doesn't like that it's at the bottom of the file, so we'll just add it to the top so that it's TSLint's happy there, or ESLint is happy. All right, it's finished building. Wow, okay, it processes all those messages. It looks like there's about 15 or so. So let's play around with this a little bit more. Let's just, refresh a few more times, see if we can get it. Cool. There's some more messages after we cleared it. Seems to be working fine. Now they're side by side, and it's pretty much live at this point. So there we go. All right, so now we're gonna add our scaler. This is a big part of this demo is that, cool, our queue's done, but we want to add a scaler in. And what this is going to do is, Keta, is it allows you to configure scaling objects in your Kubernetes cluster to monitor other services, databases, other queues, whatever, metrics from Prometheus. We're going to hook it up to RabbitMQ. All right, so they have pretty good documentation on all of this stuff. So you just kind of go in here. Here's an example of how Keta kind of interacts with the HPA, the horizontal pod autoscaler. It kind of leverages that, and this allows you to create custom configurations and plugins for pretty much any service, even your own application services. But we're going to use the RabbitMQ one. So to deploy Keta, again, like all the other examples, I've been just using the configuration that they provide for their operator using kube control, and they usually just have like a YAML. You could use Helm. A lot of these have Helm charts as well, but I'm just doing this because it's pretty straightforward and consistent. So now I've deployed the Keta operator. So now we can start creating our scalar rules here. So I'm going to update the README real quick to kind of have those values, and then for future reference to make it easy to copy and paste. All right. So now we're going to go to our Kubernetes directory. We're going to create another directory called scalars underneath there. And we're going to target our worker specifically here because we want to be able to flex our worker horizontally when we get a lot of messages in a specific queue, and scale it down to 0 when there isn't any messages so that we can save resources for other processes or just save money. All right, so this is what a scalar looks like. It's a specific object that comes with the operator. You define a name for it, and then also the scaled target ref, which is its name, so the worker ping name. We're going to shrink down from the defaults for the polling intervals and the cooldown period. So it's going to look every 5 seconds, and if there's anything in every 5 seconds, it will scale down resources, and the cooldown period for a resource is 30 seconds. So it'll keep them up as long as the metrics are set that we define here in a little bit. For this example, I just did this so that we can see it very quickly. We're going to put in our environment variables here for our queue because we are connecting to the queue with this scalar to determine how we're going to scale. And now we're going to define our triggers below specifically for this scalar. And we're going to define a RabbitMQ type. The queue name is worker ping, which we've been using, and we're going to set a value of 5 for the queue length. So every time there's 5 items in a queue, it will scale up to the in amount of that. So 5 items 1, 10 items 2, 15 items 3, etc. We're going to scale up to 3 workers, and then if there isn't any items in the queue, it'll scale down to 0. All right, so now we're going to add that particular deployment for that object, for the Keta scalar object, in to our tilt file, and that will deploy it and get it all wired up to get it ready to go. And then we'll do an example after this to see how that all works. All right. So we're going to call it keep it consistent, and we're going to call it a worker ping dash scalar so that they're all convention based here. And we're going to define the object here as a worker ping object under the scale object under the default namespace path. And we're going to put this under a Keta scalars directory. So once that's in, we're going to see an error. Okay, it's not happy. Why is it not happy? Oh yeah, because we're gonna have to lay down our resource. So our resource configuration. So we're gonna put that down here. If I could just spell it right, then it probably would work. Nope, still wrong. Oh, gotta fix that too. Double misspellings. That's great. Oh no, it corrected itself. All right, so now we're gonna just spam it a little bit and see what happens. All right, we spammed it. We're 1 to 1. If we look over here, we can see that the scalar is up and the worker ping is working. It's 1 to 1. Let's give it 30 seconds between the last time that we sent it some messages through our API. It should spin down to 0 out of 0. I'm going to reconfigure these windows real quick just to make it easier to see. Cool. Messages are processed. And yeah, we're back to 0 of 0 again. So as you can see, every 30 seconds, if there's any items in the queue, it spins down, which is great. Save resources. Let other things have a little bit more of the resource pie, if you will. All right. So now let's just take our API and have it run in a for loop and just spam 1,000 messages. That way we can, test the autoscaler out appropriately and see it scale up to its max, scale down to its to nothing. Minimum amount is nothing. All right, it's saved. Let's hit it once. Boom. All right. We should see 1,000 pop in there pretty shortly after it finishes sending them. Did. Cool. It already hit 3 out of 3 on here, so the workers are processing. Crush through all of the queue messages probably pretty quickly since they're just some console logging. No more messages are left, and this should spin back down to 0 resources, 0, 0 for this particular worker. Awesome, it did. Well, that's all I have for this video. I tried to keep this around an hour, so I covered a lot of topics really quickly. I'll throw some more details below in the video description, such as like where I posted on GitHub and everything. I hope some people find value in this demonstration. I plan on doing more of these in the future. I'm totally open for any feedback around making this content more useful, helpful to make it easier to learn. And definitely down for doing any deep dives on any of the topics I covered in this video, or if you have something that you see that is interesting, just let me know, and maybe I'll do it. Mostly focusing on the cloud native computing foundation incubator projects, as I mentioned before. But if you post something and I think it's interesting, I'll definitely consider making a video about it. So thanks for watching, and have a great day.